proper market assessment before building wind turbines in a new place. Preventing problems from occurring in the first place is obviously the most economic and most sustainable way of dealing with the maintenance issue, rather than coming back and fixing them afterwards. But you only learn these things by trying. So I'm really glad that we've had these people here to share their experiences with us, so that other people in the future can learn from their experiences. Do we have any questions for our panel here? Yes.
I'm not sure it's a question. I think that we face a lot of stuff that you guys showed here, and some of the things we tackled it one way and you probably did it another way. I don't know if we have time, but maybe we have kind of a discussion on it, because it's not just a matter of question, it's sharing information in a way that it will help people to, you know, to overcome problems.
Absolutely. I mean, the idea,
for instance, just one small tip, like you talked about the tail, and we used to have in the past a lot of stutter burn because the weight of the tail. Now, every turbine, before we raise it, we measure the moment of the tail with the weight. Now, it's not very accurate, but it gives you kind of a ballpark if your tail is really too small or whatever. So,
and like we intentionally undersize it, so that right, if we make a mistake that it furls at 8 meters per second instead of 11, and then we can slowly and incrementally increase it.
Or there were a lot of issues with the bearing. We used conical one, and we found out that after time that it's not good due to the vibration, etc. So, you know, what I'm trying to say is, not if we could find some time so we could share stuff, a dedicated time, so all of us can talk on the same level and share, and maybe find some way to write a document and put it on the website.
Absolutely. I mean, we have the small group, working group sessions tomorrow in the afternoon. We have 2 hours then, and we have 2 hours on Thursday as well. You guys are in a different working group, but if one of you was interested in joining the maintenance working group, then of course you're more than welcome. And these groups are something that exists for the purpose of the conference, and hopefully will continue to exist afterwards. And just because you've been assigned to one working group for the purpose of the conference doesn't mean that you can't dive in and out of other ones. And afterwards, as we continue, if one of the outputs, one of the things that the group decides it wants to do is to collaborate on a maintenance manual such as the one that Gail and Tripalium have produced, and if we want to add our experience to that as well, then fantastic. One of the things that we can do on the new web platform as well is we can make it more interactive, kind of like a Wikipedia style. It doesn't need to be a document that is produced and this is the final document until the next version. It can be something that someone can upload the next day when they know they have an experience that either contradicts or complements what's already up there.
All right.
Hi there. Yeah, it was very interesting to hear all those talks. The experiences I had in the Philippines with just 3 turbines were very similar, hit by lightning, water damage, mechanical damage, so very similar issues. It's maybe a question for Pedro about effective knowledge transfer. We found that we would train up at least 4 volunteers within a community, and we would train them to maintain the turbine. We then found, if we go back 6 months or a year later, that most of them would have used that knowledge to go get a job in a city. So we were training people up and losing them because I don't know if you have that experience at all.
Train women.
Yes. Well, that's true. Very true.
No, that is true.
Yeah.
That is true. They say.
That's an issue. There was an instance in Nicaragua, in the community of Coquiniquil, where we trained different system operators, 3 of them. They're all men, and one of them had other skills that were augmented already with his 10 years wind turbine skill, and then he went to another city to get a job. And also another one, Brian, that was a young guy. He got his new skills, and so he used them then to get a job at the association that installed the turbine, and also with these skills he started to study at the Technical University at the capital. And so yes, the way actually would have been to train a female community leader, but that wasn't that didn't happen because she didn't go to the training because the training was in Bluefields, and to go to Bluefields you need to take a bus for 7 hours and then a boat, and she was afraid of the water and of flying, and so she didn't go. And that's very unfortunate because she's always in the community, because she has a extended family, so to say, and so she'd be a perfect operator, and we would avoid this problem.
Maybe I just want to comment on that. I usually train the elders, or not elders, but people that you know are not going to leave, and they have an interest in maintaining it, and then I would leave videos in every house of how to do it.
We did, we did implement some of that, so training elder folk and some women to help with the finances.
Yeah, another comment on this, we think that the maintenance of these systems is a job. It's not a hobby. So we train people and we have a team in the organization, and this is what they do. They're a maintenance team. They're part of the organization. So of course there is a person in each community that we train, and they do some basic level maintenance and diagnostics, but the core of the maintenance is done from within the organization with dedicated personnel.
And just like to add, what's the travel time? The travel time from your center to the turbine?
Very short compared to some of the distances.
So this is the difference we're talking about now. So you reach them easily in a couple of hours, and that's a 3-day. Yeah?
I think this is perhaps the purpose of a market assessment, to determine in which areas is there a critical mass of users whereby you can create this service network and have a central hub whereby you can have someone who is there either full-time as, for example, a car mechanic is, so people can drive their car whenever, or someone who can do it part-time. They can be called up and they can go out and travel half an hour instead of a day.
Yes, I was just going to make a comment. So does anything like an approach to train trainers? Train people that can train people, you know, and then if they want to leave, why not? They can leave, but they train somebody before they do. Is there anything like that? Is anybody trying?
That's pretty much what we do with Passion RPM. We train, but the context is very different to Nicaragua, right? We have like technical schools with a lot of equipment in the area, so we train the teachers that already know about electrics, about mechanical, they know how to use the tools. So it's very different. In Nicaragua, you don't have that at all. So it's a completely different context. It depends on the case. Something like in Israel, they have very small distances, so it makes sense to do what they are doing. In our case, you need to train somebody that can solve the problem locally, because it's impossible for us to follow everything in place. So I think, of course, different contexts lead to different types of solutions.
I'll just like to add small context, to put a bit small information about what Vadim told. We have lots of microhydros in Nepal, and the situation is quite similar because the people you train in the community, they just, for the sake of, they find better jobs and they don't leave the situation. But the elders, after they've been trained, and particularly finding elders that are more technically there will be some people over there. So the situation seems to be a bit improved, compared to the situation where the people those are trained leaving Norway and compared to the elders. So the situation seems to be a bit improved in this situation.
For example, in this place that the program trained cooperative or persons to do the maintenance. So this is the first step when they created this program to maintain the wind power system. But then, about 2 years or 1 year, then this system was down because the problem of phones. I know this is very complicated problem, but these cooperatives don't have money to assist to the rural community, and then what you see what happened when the plan of maintenance is not operating. So it's important to train people, but see the context where we want to train some people, but we can't because there are people training the jet. So in this case, the problem is reactivate or this plan, the maintenance plan, So we have to do something in this case, in particularity. But then we have the idea to train people if we can evaluate others, our system, other winds energy systems that can provide.
I think you're right in that first, this is kind of like a testing ground, this community that you've already got a link with. So you can find out what are the main problems, how do you fix those, and then you can scale that up from, 10 to 15 houses up to 1,500 across the province, once you first know what the problem is and how to address it.
Just want to add a little thing about how it's working in France. So we have, of course, a different context, but what we do is like we ask to the owner of the turbine has to go through the process of at least one workshop, so you know how to do it. So the idea is like the maintenance is made by the owner, but after that is not the only one who have this knowledge, because we're doing through workshops. So the workshop are in one place, and you have people from different area, but often you have people, local people. So what we try to do is like putting this guys all together, but maybe like trying to set up like every year we do a party or we do something to celebrate. So we celebrate, and at the same time we try to do the maintenance. And the other thing is like we work as a network, so there is people from with the knowledge. Not everyone knows that you can find people in your area. It's not working 100%, but this is what we're trying to do.
I think that's the key thing, having maintenance services available locally. Reduce the distance to be
It's far, it's expensive, so even for us.
Usually I'm doing training with different cities. Usually what I do is I look for a village welder and a lathe guy, and I invite him to come to the workshop to learn. And usually when you tell somebody you'll learn how to build a wind turbine, even though initially they may not be interested, but usually they will come. And they serve as a link to the person that's receiving the system, so then they get the experience of being able to build it.
I think we'll all agree that building a bigger or any kind of other locally manufactured wind turbine is a great way of transferring knowledge, not just for how to build another one, but also how to fix it. If you understand what each part does through their manufacturing process, you understand how to put them back together when they fall apart and how to stop them, how to redesign them so that they don't fall apart, given the problems that you have in your particular context, whether it be lightning, humidity, heat, whatever. So we have one more question, and then we should probably go for dinner because we are already half an hour.
All right. It's a question, but probably would relaunch the debate in a different direction. But I just ask it anyway.
It's a dangerous question.
Dangerous question. What about, because we're talking about failure in terms of mechanical a little bit. We talked some about electrical. We showed batteries that blow up or the coils that have problems. What about the electric system? What about the inverters? Have you had a problem with those, and how do you solve that? Like, we're talking about training people locally, okay, so they can rebuild the turbine if necessary. But what if it is the inverter that goes wrong? What happens? What is your experience on that?
Warranty.
Or buy another one.
And just avoid the inverter to blow petrol by putting a lot of precautionary measures before the inverter, like the fuses and all these kind of stuff, because the inverter is the most expensive thing that you have. So typically we like to avoid blowing that thing up, but that happens. And yeah, that is either a warranty or you have some, every inverter has also internally some safety measures. But, if you're lucky, they are blown, and then you can put some fuses inside there.
I know some
typically you want to avoid blowing these things up. That's also costly by putting all kind of safety measure into your system.
Some inverters also, they have quite interesting warranty policies in there. Some will let you, instead of sending the whole unit back to them, will send you replacement set of boards. Then you send out those boards and you put those boards and you post them to the user, and the user can put them in themselves, take the other boards out and then post them back to the manufacturer. They'll figure out in their factory and their test bed what's wrong with them. So I really think that is kind of building on this idea of a modular electrical system. It's not locally manufactured, but again, I see the value in creating a modular system, because once you have modularity, it's easier to fix and interchange components, and if you can just send something out to the user rather than you having to go there and figure out, what's going wrong, test the voltage here, all this kind of stuff, it really makes it empowers the users to do that maintenance themselves and reduces this travel time.
But like in your experience, have you seen inverters blow very often or not at all? It's the last thing that blows in the system.
What we do first, we didn't have any case of blown up inverters. We pay a lot for them. We buy the top notch, and then they don't burn. But what we do, we use standard items in all the installations. So we have very few models, and we stock spare parts of these models. So if something fails, and the diagnostic guy, the supervisor in the community, and knows how to diagnose the system, calls us, and we find out that a charger or whatever, a controller has had a failure. We just take one from the stock, we go there, replace it, and send the one to... Now, everybody says that even in large distances, that you don't have any choice, you must have the community people know how to fix the wind turbine. I don't believe in this philosophy. How many of you know how to fix, well, you're a bunch of, but when you talk to normal people, go in the street, how many people know how to fix the electricity in their house?
They don't.
No.
They don't.
They don't. Of course
Like the communities that we work with, they're shepherds. They deal with goat and sheep, and they know to do it much better than I know. They don't know anything about electricity. Now, you need to work localized. You can't travel long distances. The way to avoid it is to make cooperative. In each point that in the cooperative somebody is being paid for, he knows what to do, he's trained for, this is his job. Like in the city, you have the electricity people, this is the responsibility. You need to take a skill like this. You can't work on a point where you put all the load on the people in the communities. They have their professions. If they wanted to do wind turbine, they would sit right now here. Obviously, after a while, some of them, if they're developed, if they're triggered, I see kids in the community where we work, they're fascinated by wind turbines. Maybe in 20 years, one of them will go to study aerodynamics, will be in one of these conferences. It doesn't happen in one day. You need to have a long, patient and long vision for this. You cannot put this load on the people in the community. It should come from them. Otherwise, you patronize it. There are no shortcuts here. So you need to build a proper scheme of, if you want to install wind turbines, you need to build a proper scheme of how to maintain it. This is my view and my experience.
I'd also add to that small amounts of the human factor in it. So I looked at a number of PV systems that had been installed for about 5 years, but with no maintenance issues. I don't think I saw any which had the charge controller left in. So a little bit of someone has come along and said, I'll make it stronger, I'll make it better, taken out the charge controller. Most of them have fuses which were wrapped in bits of tin foil. So it's very hard to get over that initial level. Nearly everyone's really great with mechanical stuff and it's amazing, but the level for certain electrical systems is going to take time. It's going to take a long time.
One comment I would like to make is what we've seen with the inverters is that, for example, in 48-volt systems, what sometimes fails with these turbines that we have in Argentina, they use a regulator, which is also locally made. If that fails, the voltage goes up a lot. It not only ruins the battery, it sometimes ruins the inverter input. So having this kind of system be made more reliable is an asset. And also a big asset is to have it manufactured in the country or somewhere near. Because we used to have only imported inverters, and you had to bring them from the US or so, and it's a big expense in the middle of La Pampa, you know. And having them built in Argentina, you reduce a lot of costs. You probably won't have it built in the community, but if you have it, you know, like 1,000 kilometers away, it's a lot cheaper than we get it from the other side of the world. So that's a good asset. And we are now having 2 sine wave inverters, and it seems to be a good solution for countries, for the whole country.
Okay, I think we would love to continue this discussion, but I imagine some people are quite hungry. So let's continue it over dinner. Just before we go, this evening we do have
another session.
We have a public session this evening. So this session will be presentations that are quite similar to the ones that we've seen today. We'll see an introduction to wind empowerment again. We'll see activities happening here in Athens, and Jay is going to go through how to design, install and maintain small wind systems. So this session is designed for members of the general public. Anyone here is also welcome to attend, but if anyone wants to go and explore the city of Athens, then they're also more than welcome to do that. If you do go and explore Athens, we need to be back here tomorrow, sometime between, we need to be back in this room by 10 to 9. So if you arrive between 8 and 10 to 9 tomorrow morning, go straight to the cafeteria. There's breakfast for free. If you arrive 10 to 9 afterwards, come straight here. We'll be coming down. In other housekeeping, also, so we've had a lot of discussions today. We've had a lot of short presentations, and many people I'm sure would have liked to have spoken for a longer amount of time. But don't fear, because we have a webinar series, which is an hour-long session on a specific topic. So if you would like to share more of what you've given us a flavour of here at these sessions today or tomorrow, then please go speak to Jessica, who is organising this fabulous series of webinars, and anyone in the world can tune in, not just people in the room. Although that's not even true, because anyone in the world can tune in now, because we do have the live streaming. So if anyone has any friends that they would like to share the conference with, please check out on the WEAthens2014.wordpress.com site the live streaming link and send it to your friends. And also, if anyone is into tweeting, then there is a Twitter feed. If you could send your tweets to #WEAthens2014. Have I got that right, Matt? I'm not a tweeter myself, so anyone else that is into tweeting, please tweet them onto the WEAthens2014. So without further ado, let's